It's again probabilities. I will tell you. So two aspects. So it's like a backup case for a backup case, which means many things can happen. Hardware failure is one. Second is basically the network connectivity can go. So in a real production cluster, you have actually multi-level switches which connect racks to other racks. So Hadoop also gives you replication in a rack-aware way, wherein suppose you keep a replica of two, likely that you both the replicas reside on the same rack. If you configure your network cluster in such a way that it is rack aware, the third replica could be even on another rack. So such failures can also be.
So the name node actually knows that there are three copies available. So typically what happens when a job is spawned is that the task goes to a node where the data, relevant data resides. Okay, so if a file has three copies, I know that node 1, 4 and 5 actually have the data. I'll send the task to node 1 where the other two are lying idle. Okay. If this particular node fails, the task tracker actually reports back to job tracker saying that okay, I am crossing. And that stops, that heartbeat stops. Job tracker says okay, that task failed. Maybe that node failed, I don't know. But I'll spawn that task on another slave again. In some cases, job tracker actually spawns two tasks. Okay, two tasks doing the same thing. But there is a speculative way of execution where the first one that finishes is the one that will give the result, the other one is just skipped. So that's called speculative execution. So that's how the job and tasks are actually synced and the failover happens.
That a cash counter which is worked for from 9 a.m. to 10 p.m. and when they are going to close the shop, it went down. The cash counter crashed. What will happen? So his entire tally is gone for a toss. He lost all the data. Right? So that is where we are talking about the replication of data. If you keep the data in only a single machine in distributed computing, that is very dangerous. Okay. So what we do